And this theorem was formulated by a French mathematician by the name of Lagrange, and that you may run across in other disciplines, in physics. But if you continue to study mathematics, you'll run across this name multiple times in the future. So what is the mean value theorem? Well, it supposes the same primary two conditions that we have in Rolle's theorem, that f of x is continuous on a closed interval and f of x is differentiable on an open interval. So the antecedents are the same. Suppose f of x satisfies the following. 1, f of x is continuous on some closed interval AB. 2, f of x is differentiable on the open interval on AB. So what happened then? Then we say that there is a number C in the open interval AB. So far it's the same, except we don't have the third condition of Rolle's theorem. The endpoints don't have to equal each other. So we have a number in the open interval such that, so here's the consequence. The derivative at this point, f prime of c, equals something that looks awfully familiar. The difference quotient, f of b minus f of a, divided by b minus a. This is an interesting result because what you see on the left side is the derivative. The derivative, if you recall, is the instantaneous rate of change. On the right side, you recognize this expression as the average rate of change. So what the mean value theorem says that if you have a continuous function at a certain interval and the derivative exists at any point, that sometimes on the interval, there'll be a point where the instantaneous rate of change is going to equal the average rate of change. Think about it along those lines. For instance, if we are dealing with distance over a period of time, let's say we drive from here to a distance of 10 miles or so. And of course, we start at 0, then we accelerate, and we move faster, and then we slow down. And the trip took us so many minutes. So we are talking about the average rate of change will be the average velocity between here and the destination 10 miles away, right? So what it means that at a certain given point in time, as we were traveling the 10 miles, at one point, the velocity at which we were traveling equaled exactly the average velocity as we travel over the 10 miles. Okay? Now, it may be more than one instant in time like that. Same as, for instance, you take the interstate and you travel, let's say, from here to Alachua or something, or even from here to Atlanta. And you have an average velocity of 70 miles per hour over this distance, but of course you start and you stop and you start and stop and the velocity change over time. So the average is 70 miles per hour, but it means that at a given point in time as you were traveling on the interstate, your velocity will be exactly the average, will be at 70 miles per hour. And it may be more than one time. You may even set up your speed control to so you have a flat rate of change at 70. But it will change. So let's look at an alternative forms. Of course, we can play with it a little bit, and we can write alternatively. We can write, for instance, f of b minus f of a will equals to f prime of c times b minus a, which is basically your point slope formula. And we saw it when we did linearization. Or if we are interested in f of b, then f of b will be f prime of c times b minus a plus f of a. So those are alternative forms of the mean value theorem. Like so. So let's write a comment here about what is the meaning, and then we'll illustrate it. So let me get my paper in order. So here's a note about the mean value theorem. Okay. The mean value theorem means, so play on words, right? MVT means that that if f of x is continuous, so I'm repeating a little bit, on the closed interval AB and differentiable on the open interval AB, then there is a point and that point will be C and f of C, right, where the following happen, where the average, the instantaneous rate of change at x equals C equals the average rate of change as we go from A to B. Okay, and that's really the meaning or the interpretation of the mean value theorem. Furthermore, if I'll pick up some kind of function, and this is an illustration. So let's say you have a function that looks like this. With endpoints at A and B as prescribed, and the average rate of change will be the slope of the secant from A to B. So let's draw the secant through AB, like so. I missed a little bit here, and we know that the error, the average rate of change, will be the slope, let's say M1 x plus B. Okay, so the error through AB equals M1. The mean value theorem tells you that somewhere on this curve there is a tangent that is parallel, that whose slope equals to the average rate of change. So the tangent will be parallel to the secant. So let me see if I can draw. Well, this is not a good. This is better, so I'll have to use a little white out. That's the problem using a pen or a pencil. So the miracle of whiteout will take care of the extra lines here. Here we go. So we can see that the blue is parallel to the red, where the blue represent the tangent. So right here, we have y equals m2x plus b. Okay? So the instantaneous rate of change at exactly x equals c, so this is the point of contact. So this is the point where we find the tangent that is parallel to the secant. Like so. So, and this we call M2. And that's what this little sketch illustrate the mean value theorem.